wavelength of first line of Lyman series for some element is 1 by lambda is equal to rz1 square into 1 by 1 square minus here. So here C is equal to mu1 lambda 1. So C by lambda 1 is mu1. So 1 by lambda 1. So here it is mu1 is equal to C or Z1 square. 1 by 1 square minus 1 by 2 square. Here it is 3 by 4. So it is. So mu2 similarly, frequency of first line of Balmer series for same element 9 minus 5. So here it is 5 CR Z1 square by 36. He is asking the frequency of second line of Lyman series. So frequency of second line of Lyman series is nu, which is C or Z1 square 1 by 1 square minus 1. So which is 8 C or Z1 square by 9. From this we can say where it is adding these two. Here I can write which is same as 27 by 36 CR Z1 square. So adding these two, mu1 plus mu2, which is 32 CR Z1 square by 36, which is 8 CR Z1 square by. So which is same as this. Answer is mu1 plus mu2. Two resistors R1 and R2 are connected. So R1 he given 300 plus or minus 6 ohm. R2 here 600 plus or minus 3 ohm. Delta R is delta R1 plus delta R2. That is 9 ohms. The percentage error in resistance delta R by R into 100. R here is effective resistance since they are connected in series 300 plus 600. So it's nothing but 1%. So distance traveled by a body in last t seconds. It is not last second, last t seconds. So that means time of ascent we know how much it is u by g. So here it is in last t seconds means in the remaining time, that is u by g minus t seconds, how much distance it traveled. So distance traveled here Distance traveled in last t seconds is equal to distance traveled maximum height h maximum minus distance traveled in u by g minus t seconds. H maximum is a known formula. So distance traveled in this time will be u uh, u into the time minus half g u by g minus t whole square, which is u square by g minus g u square by 2g, here minus of gt square. Simplification, g get cancelled, plus ut, which is u square by 2g minus half gt square. So distance traveled in t seconds is u square by 2g minus half gt square, which is half gt square. So we know proton, deuteron having same charge, only different in mass number, accelerated by same potential difference, having both are having same charge. This is related to proton. Same potential difference is applied. It's related to deuteron. So if both QEs are same, half mv1 square is mv2 square. So velocity of deuteron is here. Let us consider two plates. Here is a positive charge. So electric field will be like this. And proton as well as deuteron both are moving perpendicular to the direction of electric field. Once it enter in a electric field, for example, deuteron, there is a force due to electric field, QE, and since it is moving with some velocity in horizontal direction, finally it traces a parabolic path like this. So in t seconds, horizontal distance traveled by x is vt. In the same time, vertical distance is, because they are moving horizontally, initial vertical where Vy will be uyt plus half at square. Initial vertical velocity is 0, so the vertical displacement is half at square only. The deflection is based on vertical displacement. So here force on a charged particle is QE, which is equal to MA. Use some space for it. Here it is. Y will be finally half QE by M T square. Whether it is proton or deuteron, electric field is same, charge is same, half Y is proportional to, okay, let me write, here it is half QE. In place of T, I will write x square by V square. From this, I can say Y is proportional to, because charge is same, electric field same. So x square by V square. So deflection of proton, here T is x by V. Okay. So x square by mass of proton and velocity of proton, deuterium. So x square is 2m and V2 square. V2 here is V1 by root 2, V square by 2. So here it is deflection of proton is same as deflection of deuteron. Here, if it is a finite wire carrying current I at a distance A, at this point, magnetic field is this distance is A. Mu naught I by 4 pi d sin alpha plus L. In this diagram, one side it is semi-infinite wire. Once it is semi-infinite wire, so this angle becomes 90 degrees for infinite wire. Mu naught I by 4 pi A, and alpha here is, since it is a square, this angle becomes 45 degrees. Beta is 90. Mu naught I by 4 pi A, 1 plus 1 by root. So the current passing in upward direction, magnetic field at point O is into the plane. Even current passing along AB, the magnetic field will be into the plane. So both are in the same direction. So here, magnetic field at O due to part AB, distance same, semi-infinite wire. So this will be mu naught I by 4 pi 1 plus 1 pi. So both the magnetic fields are in the same direction. We can add it 2 times mu naught I by 4 pi root 2 plus 1 pi. That is mu naught I 4 pi A. Finally, it is mu naught I root 2 plus 1 by 2 root 2 pi a. The ratio of kinetic energy of a projectile at the point of projection to the maximum height. At the maximum height, so it has only one velocity horizontal. Kinetic energy will be this 1 is to cos square. He given this one as 4 is to 1. So theta is 60 degrees. The ratio of maximum height to range sin 2 theta to sin theta cos theta range is tan theta by, so theta is 60, tan 60 root 3 by u square sin square theta by 2g. A ball of mass m is moving with a velocity v. A player is kicked in a direction perpendicular to it, maintaining same speed. So the impulse is change in momentum. P initial here is mv. P final will be change in momentum is mvj minus mvi. So pf minus pa magnitude which is root 2 mv. A positively charged particle is projected parallel to the current carrying conductor in the direction of current, the charged particle. Force on a charged particle, let us consider this as along y-axis, projected parallel. So current is passing in y direction. So by right hand thumb rule, magnetic field direction will be into the plane. That is minus q times j cross I minus qi. That means force act towards the cable. A cell having EMF E and internal resistance R and connected to an external resistance capital R. So here current is I into R plus R. So the power delivered is I square R. External resistance is fixed. This we can write. So power is maximum if denominator is minimum. It is possible when R here is R. Internal resistance and external resistance are same, then maximum power will be delivered. So then the P maximum will be E square by R here. R is 2R, that is 4R square, which is E square by the 3 point masses of each mass M are connected by three light rigid rod and system is rotating about one of the rods. Let us assume that system is rotating about AB, moment of inertia. Moment of inertia, so about this axis, masses are on the axis. With respect to them, there is no inertia. Inertia is there only due to this mass. Draw a perpendicular. It bisect opposite side. So it is L by 2. Say some CD. CD will be root of L square minus L square by. So this CD will be root 3 L by 2. So M into R square, that is 3M L square by, according to first law of thermodynamics. dq is du plus dw. dq is amount of heat supplied. So du is increase in its internal energy. dw is work done. So in isothermal process, temperature is constant. Change in internal energy is a function of temperature. No change in temperature, internal energy 0. That means dq will be 0 plus dw. Whatever heat is supplied, entire heat is utilized to do work. In all other processes, some amount of heat supplied is utilized to increase its internal energy, so work done becomes less. So here correct option is isothermal. Here acceleration due to gravity at a height h 1 minus h by 2h by r. That is g dash minus g is minus g into h by r. Minus 2h by r. He given g dash minus g by into 100 is 2%. 0.2%. Acceleration due to gravity decreases by 0.2%. At a depth d, acceleration due to gravity is g into 1 minus h by r, which implies g dash minus g by g into 100 is minus h by r into 100. Here it is minus 2h by r into 100 is 0.2%. From here, h by r is 0.1%. So it decreases by 1%. Here, current
changes with respect to time. When there is a change in current, definitely EMF is induced, the potential difference. So here induced EMF is equal to minus L di by dt. Induced EMF is minus L di by dt. Little mathematics. So here it is. This is x-axis, it is y-axis. Say this is A, this is B. This line equation is x by A plus y by B is some constant. Here it is, other way, so slope is negative. Slope of this line greater than 90, slope is tan theta is negative because theta more than 90. Here in place of x and y we have a I and t. So I plus t is constant. So that is I by something plus t by something is constant. Once you differentiate it, di by dt will be minus of some quantity. Let us say a comma b, di by dt will be minus b by a. So EMF induced will be minus L di by dt. So this is LB by A. So L is constant, B by A also constant. EMF will be, EMF induced is negative. Sorry, here it is positive and constant. So here in fourth graph, EMF is positive. In third and here induced EMF is varying. This can't be the answer. Here also it is can't be the answer. Here EMF induced is constant, maybe this or maybe this. But among these two, which one is correct means we have to observe another part of the graph. So the line is like this. We say y equal to x, slope positive. So this line equation, I can say y is equal to x plus k. So it is say k comma 0, then passing through. Here he given in terms of I comma t at 2t. Here it is I is equal to t minus something. So di by dt is nothing but slope of this, positive, right? So now EMF induced, here is minus L di by dt. Minus L di by dt is positive. That means EMF induced is negative. So this can be the graph for four options. Here EMF is induced is constant and negative. So in the next question, when the spring block system oscillates with a time period, so this is known derivation for us. Mass m, spring constant k, time period is 2 pi root m by k. So now in the next case, what he did is this block is partially immersed in a liquid. Let us say some h part uh, to this height, it is immersed in a liquid. Then what will be its time period? So additional thing here is once it is immersed in a liquid, there will be a restoring force kx as well as force of buoyancy will come. So initially net force will be in upward direction and x naught is the displacement of the spring. When it is slightly displaced from the mean position through a distance delta x, then net force becomes minus k plus a rho g of delta x. What is this a rho g means? Force of buoyancy is equal to volume of the liquid into density of the liquid into g. So volume of the liquid is area, length here is h, density of liquid is rho, that is ah rho g. That is the force of buoyancy. Now time period becomes 2 pi root m by k plus a rho g. So this is T1, T2. So it's very obvious T2 by T1 will be root of k plus a rho g by k, which is greater than 1. So here T2 by T1, 1 minute, which will be k by k plus a rho g, which is less than 1. So the time period decreases. In electrostatic potential at a surface of a solid of a charged conductor, electric field inside a charged conductor is zero. So dV zero, potential is constant inside the solid charged conductor. Work done is equal to Q times VA minus VB to move charge from surface to the center. At surface, let us say potential, at center VB, but VA and VB are equal. So work done to carry a charge Q from surface